What if I told you that some of the most important construction projects on Earth are happening in a place where humans can't survive for more than a few minutes? Deep beneath the waves, a vast network of pipes, cables, foundations. It's a world of crushing pressure, total darkness, and relentless currents. We've managed to build things down there, an incredible feat of engineering. But how on earth do we make sure it all stays in one piece? Building things on land is, relatively speaking, straightforward. You have solid ground, you have air to breathe, you can see what you're doing, gravity is predictable. Underwater construction throws all of that out of the window. First, there's the pressure. Every 10 meters down equals 1 atmosphere more pressure. It's enough to crush a conventional submarine like a tin can. Every piece of equipment must be engineered. Materials don't behave the same way. Welding becomes a high-tech procedure. Seawater is corrosive, it attacks metal, it attacks concrete. Biofouling is a major headache. Marine organisms colonize the seabed quickly. Barnacles, algae, mussels. Their crusts hide problems, add weight and drag, and can jam moving parts like valves. Underwater, you fight an ecosystem claiming your structure as reef. Accessibility is limited. On land, a technician in a lift tightens a bolt. Underwater, a similar bolt needs a major operation. Charter a multi-million-dollar vessel. Wait for a weather window with calm seas. It's an entirely different discipline of engineering. Once a structure is built on the seabed, the challenge isn't over, it's just beginning. A subsea pipeline isn't just a simple pipe. Segments, joints, valves, supports stretching for hundreds, sometimes thousands of kilometers. Each one of these components is a potential point of failure. A welded joint, for example, is under constant stress from the internal pressure of the oil or gas it carries and the external pressure of the ocean. It's also subject to temperature fluctuations and the corrosive effects of salt water. A tiny microscopic crack can, over time, grow into a catastrophic failure. The consequences of such a failure are severe. A leak from an oil or gas pipeline can have a devastating environmental impact, harming marine life and coastal ecosystems for decades. It's also a massive financial loss for the operator and can disrupt energy supplies for millions of people. For subsea data cables, which carry over 95% of all international internet traffic, a break can sever communications between continents. It's a high-stakes game of hide-and-seek with disaster. Traditionally, inspecting these structures has been a painstaking process. A remotely operated vehicle, or ROV, tethered to a ship, would slowly fly along the length of the pipeline. A pilot on the ship would watch a grainy video feed trying to spot anomalies. This is incredibly tedious and prone to human error. Imagine staring at a screen for an 8-hour shift, watching kilometer after kilometer of mostly featureless pipe go by. It's easy to miss a small crack, a patch of corrosion, or a section where the seabed has eroded away, leaving the pipe unsupported and vulnerable to currents. The data collected was also a problem. You'd end up with thousands of hours of video footage that someone then had to review, catalog, and analyze back on shore. This is where artificial intelligence enters the picture. Instead of just sending down a dumb camera on a robot, we are now sending down autonomous underwater vehicles, or AUVs, equipped with a suite of advanced sensors and, crucially, an AI brain. These robots are no longer tethered to a ship. They are given a mission, like, inspect this 50-kilometer stretch of pipeline, and they execute it on their own. They use sophisticated navigation systems, often combining sonar and inertial measurement units to know exactly where they are without GPS. They can follow the pipeline with a precision that a human pilot would struggle to match. The real magic happens with the data they collect. These AUVs aren't just recording video. They are using high-resolution cameras, laser scanners, and acoustic sensors to build a complete three-dimensional digital model of the pipeline and its surroundings. A laser scanner, for example, can measure the exact geometry of the pipe, detecting dents, buckles, or deformities with sub-millimeter accuracy. Acoustic sensors can be used to check the thickness of the pipe wall, looking for internal corrosion that would be completely invisible to a camera. This is a level of detail that was previously unimaginable. The AI on board the vehicle and back in the cloud then gets to work. It can process this vast amount of data in real time. An AI model trained on millions of images of healthy pipes and damaged pipes can automatically flag potential issues. It can spot a crack far smaller than the human eye could ever detect in a murky video feed. The deep sea is not a predictable environment. Currents can change direction and strength unexpectedly. Visibility can drop to zero if a robot's thrusters stir up sediment from the seabed. To operate effectively here, an AI needs to be more than just a pattern recognition machine. It needs to be adaptive. It needs to be able to react to its environment in real time, just like a fish or a marine mammal would. Modern inspection AIs are being designed with this in mind. They use a concept called situational awareness. The AI is constantly taking in data from all its sensors, sonar, Doppler velocity logs, pressure sensors. It fuses all this information together to build a dynamic internal model of its immediate surroundings. If a strong cross-current starts pushing it off course, the AI doesn't just blindly increase thruster power. It understands the force acting upon it and calculates the most efficient way to counteract it, saving precious battery life. This adaptiveness extends to the inspection task itself. The use of AI in underwater inspection might seem like a niche industrial application, but its impact is far-reaching. The most immediate benefit is human safety. Commercial diving is one of the most dangerous professions in the world. By taking humans out of the loop for routine inspection tasks, we are fundamentally reducing the risk of accidents. Robots don't get decompression sickness, and a lost AUV is a financial setback, not a human tragedy. Then there's the environmental protection aspect, which is enormous. Proactive maintenance guided by AI is the key to preventing spills and leaks before they happen. An AI that can detect a microscopic flaw in a weld or a small patch of corrosion and flag it for repair is a powerful tool for environmental stewardship. It allows operators to move from a reactive, clean up the mess approach to a proactive, prevent the mess strategy. Furthermore, the AUVs themselves are more environmentally friendly. They are often battery-powered and far more efficient than a large diesel-guzzling support vessel that has to stay on station for weeks at a time. The economic benefits are also significant. An autonomous inspection campaign can be completed faster and with fewer resources than a traditional one. A single AUV can do the work that once required a large crew and an expensive vessel. And finally, this technology is accelerating our understanding of the ocean itself. While these robots are inspecting pipelines and cables, they are also collecting a huge amount of incidental data about the marine environment. So, to recap, we build incredibly important things in the deep sea, an environment that is actively trying to destroy them. Keeping an eye on these structures has historically been dangerous, expensive, not very effective. Now, we are using autonomous robots, powered by artificial intelligence, to do the job. These robots can navigate on their own, use advanced sensors to see things humans can't, and adapt to the unpredictable conditions of the deep. This is making underwater infrastructure safer for people, better for the environment, and more economically sustainable. It's a quiet revolution happening far from sight. This is not the end of the story though, it's just the beginning. The next generation of these systems will be even more autonomous. We are moving towards a model of resident robots. These AUVs will live permanently on the seabed. The ultimate goal is a fully autonomous maintenance system. The AI would not only find the problem but also fix it. This technology is a perfect example of how AI can be used to extend human capabilities into environments that are beyond our physical limits. The world beneath the waves is the largest and least explored part of our planet. As we continue to rely on it for energy, data, resources, we will need smarter and more capable tools to act as our responsible stewards. So the final question isn't just about how we will use AI to maintain what we've already built, but what will it allow us to build next?